Okay, in this tutorial, I'm going to show you how to download openEMS. So we just type in openEMS, not that one. So openEMS, just into, Google or Firefox or whatever. Not this link, not that one. It is this one. So openems.de, and actually the GitHub for it is this one. So that openEMS. So if we go here, we check the website. That's the same website. That's good. And so there's actually 3 different documentation pages for actually going to download it. We're going to use this one called stable documentation. So we go there, then we go to install on the left side here, then we go to requirements on the left side here, and then this is the instructions for Debian Ubuntu, which is what I am running, right? So 2404. So what we want to do first is just basically copy and paste until stuff doesn't work. So that first link, yep, that is a lot of packages because we're trying to build from source, but that sort of makes sense, right? So we press yes. Just make sure whenever you're, trying to run a install script that there's nothing, it's kind of hard to tell here, but you might see stuff like, oh, it's trying to remove XTG desktop portal, and that's when you know that something's gone wrong. So just do a quick dummy check, make sure you're not removing packages or adding packages that don't really make sense. This is a bunch of libraries because we're trying to make something, so it sort of makes sense. Yeah, so that looks like it should almost be done. That's done. Cool. So we try doing this next part, and it should just work well. Okay, 282 megabytes sounds reasonable, and it just looks like it's more Qt tools, I guess, for app whatever CAD. So after that, it looks like we're going to be downloading Octave, which is sort of like a MATLAB open source version. So as you can see, I have a pretty good internet connection as well, so yours might actually take quite a bit longer. That's fine, but yeah, just bear in mind that your mileage may vary. So we try running that, and it says lib octave dev, unable to locate it, right? So what does that mean? If we go to Octave GNU, which is the tool that we're trying to download, and we go to the download section, and we go to GNU Linux, and we go to packaged versions, instructions for each are on the wiki. We go to the wiki, and from the wiki we go to Ubuntu, which is the same as Debian, just as a quick note. We have the Octave, lib octave dev in the newer versions is actually just octave dev. So we can go back to that command and change that to octave dev. And actually I'll do one more thing because I saw it on here, which says octave doc. I'll just, install that because why not? So octave doc, octave, and octave dev, and that is now working. So we'll press yes. And I think I can probably close this out because I'm not going to be touching Octave anymore. Yeah, looks like that's just about ready. Okay, and that's installed. And so with that downloaded, we can now sort of go to the next thing, which is just Python. So we'll go here, copy and paste that. So that looks like it's just about done. As I say, I have a pretty fast internet connection, so if yours isn't going as quick as this, then, that's fine. It'll just take a bit longer, and that's all good. So that's done now. So now we go Paraview, try and install that. Another 450 or so megabytes. I guess make sure you have enough space on your disk. Looks like that's just about wrapped up. So I'll copy this command as well. That looks like that's done. So we'll do pipe to mat, if memory serves, is import board sim files to openEMS. So that's basically, you can take stuff from, I think, KiCad, which is a pretty, I guess, what do you call it? PCB design software. Yeah. So it's like an alternative to Altium and stuff. So it looks like that is now done as well. So we are done with the requirements step. Now we have to actually do the, clone everything and build everything part. So pressing over here to go clone, build, and install, we're going to copy this link, go there, and paste it here. And just to, I guess, sort of make sure that we're in the home directory. So now I'll do that, run that. And so it's now going to clone that into, as you can see, my home directory. and then we'll just go into the directory, I guess. And then the next step will be to actually build and install it. So they have an install script, but they do say that there's some options that you can use to try and, I guess, have Python support, use the circuit toolbox thingy, which will tie into Octave or MATLAB. We're going to do that, and then also this hip2mat stuff, which is probably also useful as well. So instead of doing this first command, I'm going to copy this command, and then I'm going to go into openEMS project, make sure we're there. We can see the update openEMS script. Okay, so just before you run the install script, one quick note is that you won't actually have all your Python dependencies. So the one thing that you're missing is this. So just make sure that you run this command before you run the next thing. Okay, back to the video. We'll just run that like that. And so now we wait. Yeah, so what we want to do now is we still have to do some stuff in Octave. So we open up Octave. And so we go over here to edit and then set path. So here down the bottom, okay, well, it looks like it actually kept my information from the last time, but what you'd want to go do is, let's actually just remove these just to show you. And so we go add folder, single folder, and then from here we go into the installation directory, openEMS, and then we go, I believe, share, and then first thing it says to do is, it's actually here in the terminal. So first thing it says to do is add the openEMS MATLAB. So we'll go back into here, openEMS, MATLAB, and then press open. So if we go into here, we should see, I think, up the top that it's added that folder. So I'll just bring it down the bottom just so that I can see, okay, I've added this to the path. And the next thing is to add another folder. So we go from here, again, in the share folder. I believe that it's CSXCAD. So we'll go here, CSXCAD, MATLAB, press open, go into Octave again, and we'll see, should be here up the top. Yep. Move to the bottom, and then the last thing it says we can do is, I believe, the hip2mat and the circuit toolbox. Yeah, okay. So we'll go over here. That's fine. Add a folder. We go share, hip2mat, MATLAB, open. So it's up the top here, so I'll just bring it down again. And then once more for the what was it? Circuit toolbox, I believe, right? Circuit toolbox, cool. So we do that, press open, and then go back here, make sure that it's actually added. And that is added, so we will bring that to the bottom. And then press save. Cool. So that should be good. We'll actually test it in just a second. But there's one more thing I also want to do, which is we go back here to the guide and we'll say, after the build is complete, you want to add this so that you actually have the executable in your path. So that basically means that when you open up your terminal like this, it's actually going to work for me because I still have it in there. But if I go openEMS, it'll actually run, as you can see, it'll actually run the program. And the reason I have that is because if we go into my bash rc, so if I go vim.bash rc, and we go to the very bottom over here, you can see I actually have that added. So what you'll want to do is probably go into, I mean, you might have, let's go WQ just to close it. So you might have Nano installed instead, which is a pretty common one, I think, that just ships with a lot of distros or Ubuntu, I don't know. So what you'll go is nano and then .bash rc, assuming you're just using bash and not something else like fish or whatever, I don't know. And so if you just go down, so I'm just using the arrow keys just to go down, or I think you can also scroll. Yeah, it looks like it supports scrolling. So I'm at the very bottom just so that it's a bit easier to see. I'll do a hashtag or a pound, whatever you call it. And I just want to, this is just for me to remember. So add openEMS to, right? And so we go back here, and it says to use this. When we actually copy paste it, there's an issue with the quotations. So I'll copy and paste it, but these are sort of formatted weird, like we have to see on the cursor. So what I'll do is I'll delete that, and I'll press the double quote button on my keyboard. If I do it on the other side, you should see the formatting looks a bit better. So it's actually figured out, okay, this is this is what you want. So if I now want to save the file, I press Control, hold Control, and then press O. File name to right, just press Enter. And if I press Control X, then that will save it. And if I want to check that it's there, there's this command called the tail command, so that will show you the last few lines of the file. So I'll go tail.-rc, and then we can see down the bottom there, we've still got that over there. So if I go close the terminal, go back here and close this terminal, and then I try opening the terminal again. So I'm going to actually just share a shortcut. Control-Alt-T should just open up the terminal if you press that. I'm opening it full size, and so now if I go to open it full size, I press the Windows key and arrow up, I guess. And so now if I go openEMS, it works. So that means that it's in the path, which is nice. So what we want to do next is, I believe, check the installation. So if we go to this link and check, it will show us how to check that we've actually got everything set up. So openEMS, that is, as I just showed, working pretty well. So if we go to AppCSXCAD, if I try running that, AppCSXCAD, looks like it opens up something. I'm not really sure if these are like critical errors or not, but I'm just not worrying about them right now. So that opens, right? So that's fine. And then the last thing to check is MATLAB and Octave. So I'll press the Windows key, go to Octave, which is it open? No, it's not. So I'll go here. There might have been like a, open first time dialog for you when you opened it, but you just click through and, test what you want. And then what we're going to do first is to make sure that CSXCAD is actually working. So we'll do, and this is like a command prompt sort of thing. So we'll type in init CSX, and it looks like it's actually outputting something, which is good because we want it to output something. If it says undefined, then it isn't working, but it's working. If yours isn't working, then obviously leave a comment and I can try and help. And then the other thing to do is check if openEMS is working. So we're going to copy that command directly, paste it, and press enter, and it looks like that's also working, which is good. And then the last thing we're going to do is try and run an openEMS thing, but it's there's no actual XML, so it should fail, but it will fail by saying, hey, this thing isn't working, not, hey, this isn't installed. And as we can see, openEMS tries running, it says, hey, this doesn't actually exist, and then it's like, oh, that's not working, and that's what they also say. It presents an error message, the call itself was successful. Last thing to check is we'll close that out, Python. So going back here, I go Python, here's one more thing as well. When you're using openEMS, you basically want to, it uses what's called virtual environments, which basically means within like a dummy shell sort of thing. I don't really know how it works. But if you go source, and then you go to the installation directory, openEMS, I believe it's venv, and low battery. We'll sort that out later. And then venv bin activate. You'll now see that there's a venv thing over here. And so basically that means that whatever libraries are inside of this folder, we can now access them without too much, like annoying around with stuff. So if we try opening up Python, I just typed in Python, that should be the version that comes with this virtual environment. So now if I try doing import CSXCAD, and there's no error, if it wasn't actually in there, then it would have said, module find error or something, like it can't figure out what I'm asking for. So that works. And then if we check import openEMS, that also works. Yeah, basically we can see that it's working. So I'll just close that out. I press Control D for reference, and then yeah, module not found error, but we didn't get that, so it's working. So that's good. So now if we go. I don't really think we want to update. I'm probably not going to update because I don't even know how to use it. But basically, now we have a working version of openEMS on this thing. And I guess just to round it out, let's try doing a tutorial. Let's try opening up one of those tutorial example things. So if we go into, remember that we git cloned the openEMS Git project. So we'll go into there. I believe if we go into the openEMS folder specifically, there should be an Python folder. Yeah, that's right. So we could actually try Python or MATLAB or whatever, but I'll go into Python. And there are some example files in here, like tutorials. So I'll go cd tutorials, ls, and then we've got a bent patch antenna, whatever that is, a helical antenna, some sort of notch filter, a sphere, I guess, a rectangular waveguide, and then a simple patch. I'll just try, honestly, let's just try the simple patch antenna. Why not? So we'll go Python, remembering that we're still in the virtual environment. So if you opened up a new terminal, just make sure you're on that like source command. I've already got that, so I'm just going to go Python. And I'm trying to run the simple patch antenna thing, so I'll do that. And then we should see openEMS opens up. It's trying to do stuff. It says, okay, we've created something. We're trying to, run a simulation with whatever. I don't really know what's happening at this point. Okay, but basically, it looks like it's working, and then after a little bit, it'll, chuck through this problem, and then it will try and show us what exactly is happening with the simple patch antenna. So I think it shows some sort of graphs. I'm not really sure, but yeah, openEMS looks like it's working, and we now have a frequency graph of some sort, another frequency graph of some sort, and another frequency graph of some sort. I'm not really sure what I'm looking at, but yeah, that is that. So hope that made sense.